Okay, so this lesson I'm calling the chain rule help. It's messing with my head. So this video, I highly recommend that you have my free guided notes. This is a video that you want to watch if you get the idea behind the chain rule, but you get like lost when you see it's mixed with other rules. So I highly recommend you go to divideandconquer.com and get these free guided notes so that you can really work on this, because I'm really going to try to help you master this in this video. So the chain rule, I've broken down the idea behind it in another video. I will drop a link to this whole thing in the description. So a big thing with the chain rule is knowing like how functions are composed. So you can watch this video if you need a refresher on that. But the first tip I want to give you, if you feel like you get lost with it, is that the chain rule will feel slightly easier if you have your basic derivatives memorized. So just to see how you're doing with that, here's a flash quiz. Now, if you know that you've got this, you can look in the description and just skip over this. But otherwise, I highly recommend that we just see how well you know these derivatives. So these are actually all listed in the guided notes. So this is a little flash quiz for yourself. So you can pause the video here, get through this list and also the next list, and I'll show you the solutions. Okay, so here are all of the derivatives for this first part of our flash quiz, okay? And then I also have all of the trig rules. So again, like if you know these, it's just gonna make working with the chain rules so much more straightforward, I guess. So again, pause here. And here's your answers. So if you don't have these memorized, like you have got to get on this because it's going to make a huge difference with the chain rule. Okay, so now let's talk about tip number 2. If you've got those memorized, you want to ease yourself into complexity with the chain rule, or you could just watch this video. So what I'm going to do is I'm going to start with some basic chain rule examples. So I've got these 3 examples here. So I want you to pause the video and do these 3. Hit play when you've got it. So starting with A, so I always like to identify my outermost function and then my innermost function. So if I go ahead and take the derivative, so I've talked about this in other videos. So you start by taking the derivative of the outer functions. The derivative of sine is cosine. And then you leave that inside function intact, and then you multiply this by the derivative of the inside function, and the derivative of 7x is just 7. So here my derivative is going to be 7 cosine 7x. Okay, so moving on to G here. So now my outermost function is this e function and the innermost function is x squared. So, okay, now if I take the derivative of the outer function, so the derivative of e to the x is just e to the x, but instead I write e to the x squared. I leave that inside function intact. And then I multiply that by the derivative of the inside function, which would just be 2x. So then to just make this look, you know, nice and pretty, we're going to call this 2x e to the x squared, okay? And finally, so for this h of x, so trust me, this is going somewhere. There's a reason why I'm doing all this. Okay, so my outer function in this case is this thing to the 21st, and then the inner function is this part right here. So taking the derivative of the outside, this will be 21. I leave this inside function intact, and then I multiply that by the derivative of the inside. So now if I simplify this, I'm going to get 63 3x plus 7 to the 20th. Okay, so here's the deal. You want to write these 3 derivatives down and keep them next to you for the rest of this video, because I'm now going to basically, anytime I use the chain rule, it's going to be one of those 3 things, and I'm going to make this more and more complicated around those rules. So if you didn't write those down, I recommend that you go back, write those down, have these in front of you and the derivatives in front of you. This is a visual cue to kind of get the chain rule to stop messing with your head, okay? So that's why you want to write these down. Now keep in mind, learning math is an active process, not passive. So if you are just watching this video, I don't recommend that if you are struggling with the chain rule, okay? You've got to watch this, you've got to pause, you got to think, and you will get the chain rule, but you've got to take an active role in watching this, all right? So like I said, so now we're going to push these ideas and we're going to add in the product, quotient, and more chain rules, okay? Okay, so starting with A here, so I've got x times sine of 7x. So here's the deal. I think when people learn chain rule, then they like get hyper focused on using it. And so sometimes people look at this and go, I see the chain rule here, so I got to use it. But wait, so you want to like take a back step here and recognize this has really the product rule in it. And that's actually what's going to kind of dictate the order here. So you've got really like these two functions. And so I think when you're learning the chain rule, you also have to learn to like kind of pause and say, okay, I've got to do the chain rule here, but I'm not going to worry about that right now. And by the way, we already know what this derivative is because we took it. That was the whole reason why we did that. Okay, so let's work on the product rule. So the product rule says that I just start by taking the derivative of this guy, which is just 1, so I'll write a 1 here. And then I multiply that by the other function. So the chain rule has nothing to do with this first part, okay? Now, let's see, I'll move over here. Now I leave the x alone and I take the derivative of this guy. And we already did that, right? So I'm actually just going to rely on the work that we did earlier for this. So this is what I would write down. So that's what's going to go in here, this cosine of 7x times 7. So I didn't worry about the chain rule until it was really necessary. So it's like kind of learning to turn your brain off in some ways, which is actually like, I think that's a real skill to have with math. I think like our brains have a tendency to be like, okay, I know I have to use this skill, and then they almost like psych us out and make the problem harder. So here is the solution in this case, okay, or the derivative, not the solution. Okay, so now I'm gonna try this again. So notice I've added like more noise here. So now I have this whole longer function that I need to take the derivative of. But like when you think about this, like this derivative right here is just gonna fall out, right? So you really just gotta worry about this part. So I highly recommend that you like try pausing now and just taking this derivative and then hit play when you're ready. Okay, so now I've got the product rule again. So I've got these two pieces. I'm not even really worried about this because I know this is just 0. So, okay, so now I've got g prime of x. So this will be, so first I take the derivative of e to the x squared. This is where I need the chain rule. So this becomes e to the x squared times 2x. And then I leave that tangent function alone. And then I leave the e to the x squared alone, and I take the derivative of tangent x, which is secant squared x. Okay, so there's all my pieces. And then to make this look nice, like there's not a lot of simplification I can do here. So this will be 2x e to the x squared tangent x plus e to the x squared secant squared x. Okay, I got that all in there. So now let's move on to what about like having the quotient rule. So again, it's like I see I've got to use the chain rule here, but the bigger thing here is I've got to use the quotient rule for all of this, right? So that quotient rule is really what's going to dictate this. And then when I get here, then I'll just kind of work with the chain rule as I need to, all right? So let's start by taking, let's see, first I've got to take the derivative of the top function. So this is where I need to use the chain rule, right? So we already did all that work. So if I write out that work, that was 21, 3x plus 7 to the 20th times 3. And so it's the derivative of the top. So sometimes when you're working on the chain rule, you have to remind yourself, what is that overarching rule? So it's the derivative of the top. I just took that derivative times the bottom function. Okay, that's the first part. Now I leave the top part alone, and I just take the derivative of the bottom, which is just 9. Oops, not 9x, just 9. And then it's all of this divided by 9x squared. And so now from here we just like simplify this. And you just kind of do the best you can. And there are multiple ways that you can simplify some of these things. So I know that's where this can get a little bit tricky. So in this particular case, so probably the first thing that I want to do is multiply like all these numbers together. So let's see, 21 times 3 times 9 is, let's see, this will be 567x times 3x plus 7 to the 20th minus 9 times 3x plus 7 to the 21st, all of this over 81x squared. All right, so here's the deal. You can simplify this a bit more, right? So first of all, 9 goes into this this and this. So I'm going to factor a 9 out for sure, but also notice you got 3x plus 7 to the 20th and 3x plus 7 to the 21st. So I can actually factor out this 3x plus 7 to the 20th, right? So I've got to make myself a little more room now. So now I'm going to factor out 9 times 3x plus 7 to the 20th. Okay, so let's think about now on top, what am I left with here? So 567 divided by 9 is 63x. And then I factored out this 3x plus 7 to the 20th. That's here, so I can drop that. And then I factored out this 9, so I don't have to worry about that. So I'm just left with one factor of this 3x plus 7 to the 20th, right? Because I factored out the first 20 of these, so I'm just left with one factor. So it's minus 3x plus 7. And then all of this over 81x squared. Okay, so now I can see in how I factored this, I can actually divide both of these by 9. So like part of this is like you really just got to kind of take your time here to work through this. So now I can finish this. I can divide the top and bottom by 9. So this just becomes 3x plus 7 to the 20th. Then simplifying this part here, this will become 60x minus 7, and then this will be 9x squared. So there's like your most simplified answer. So you really got to like take your time with this and really kind of notice all the details. Like just take a deep breath and slowly and methodically work your way through. A lot of times when you get to this part of the derivative, it really comes down to an algebraic exercise, and the thing that kills people with algebra more than anything else, it's not even not knowing the algebra, it's like getting frustrated and being like, I don't want to deal with this. If you are slow and methodical, you will get through it. Okay, so now look at what I've done here. So I've got e to the x squared sine 7x. So now I have the product rule. Again, it's like we're not letting our brain say, I see the chain rule. Instead, it's like I see the product rule. That's really what I see. And then I just have to use the chain rule as a consequence. So here's one function. Here's the other function. So I'm just going to go ahead and use the derivatives since we already know what they are. So the derivative of this guy we already talked about. This was 2x e to the x squared. So I have that derivative times the second function, right? And then I leave the first function alone, and I multiply that by the derivative of the second function. So we've already looked at that a few times. So like as you go through these, you want to notice, okay, I've got to use that product rule, and then it's just if you have to use the chain rule, like I just so happen to have to do that. So then my final answer in this case, let's see, this will be 2x e to the x squared sine of 7x plus 7e to the x squared cosine of 7x. Okay, so now once again I have like two chain rules here, and by the way, like we're almost done with these, and then I'm gonna throw something random at you. So if you're feeling good about this, that's good. We're gonna have an ultimate test in a moment here. So anyways, so now I'm going through this. So I know I've got to use a chain rule, but this is really being like overshadowed by the quotient rule. So maybe you want to pause and try this on your own. Hit play when you're ready. So okay, so taking the derivative of the top, I know that's 2x e to the x squared, and I multiply that by the bottom function. I don't touch it. And then I take the derivative of the bottom function, which I'm just going to go ahead and write that out. So let's see, that was 63 3x plus 7 to the 20th. So there's the derivative of that one times e to the x squared. So there's like all the pieces of that, right? And then I divide this by 3x plus 7 to the 21st, and that is squared. Okay, so now this is another one of those ones where like there is some major simplification that can happen here. So take your time with this, right? So like looking through this, I see these e to the x squareds, and then once again I notice this 3x plus 7 to the 20th. I can't factor out any other number, but work your way through this now and see how far you can get with this. I really want you to pause this and try this. Hit play when you're ready. So I'm super running out of room here, so I'm gonna just give myself a whole new place to work. Okay, so I'm gonna factor out e to the x squared. So let's see, looking through this, I've got these e to the x squared, and then I'm also gonna factor out this 3x plus 7 to the 20th. So this will become 3x plus 7 to the 20th. Okay, so what does that leave me with? So that leaves me with, for this first term, just 2x and 3x plus 7, okay? And then for this second part, this leaves me with minus 63. So that actually really cleans up things quite a bit. And then in the denominator, so this becomes 3x plus 7 to the 42nd. And so now you can see this term here and these can actually cancel out. So I can subtract 20. This can factor out entirely. This will become 42 minus 20. So I can use my exponent rules here. Okay, so now if I were to finish this lovely problem, this becomes 6x squared plus 14x, sorry, that 14 looks terrible, 14x minus 63 over 3x plus 7 to the 22nd. And so there you go. So, you know, we just had to kind of take our time with simplifying that one. Okay, so now I'm trying to throw in a little bit of a curveball here, but we're still dealing with like those same chain rules. So these kind of also throw people off, I think, because it's like, oh, I see like all these chain rules and I'm not really sure. So when you look at this, so try, like you can see multiple chain rules, but where is that outer function? Like I cannot stress identifying your functions enough. This is the outer function. And what is the inner function? Really all of this, right? Now your brain might be saying, oh, but you got to use the chain rule here, but you'll worry about that when you get there, okay? So, oops, and I forgot to put an f of x. Let me put an f of x right there. So sorry, my bad. So now I've got f prime of x. So I'm going to start with that outer function. So the derivative of sine is cosine, and I leave the inside intact. And now I'm going to work on getting to that inner function. So the derivative of 7x is 7, but now as I work through this, oh, now I've got to use the chain rule again, right? So now this is where I say, okay, as I make it here, here's my outer function, here's my inner function. So I start this process over. So the derivative of e to the x would just be e to the x. However, this will be e to the x squared because I have to leave the inside function intact. And then I multiply that by the derivative of the inside function, which is 2x. So I did have to use the chain rule again here, but like I had to be patient, okay? So now, let's see how we can simplify this. There's not a whole lot you can do to simplify this one, honestly. So I could just rewrite this as 7 plus 2x e to the x squared times cosine of 7x plus e to the x squared. Okay. So one thing I want to mention here, I hear also a lot like people kind of freak out about simplifying. So there's not always a perfect way to simplify. I have looked up like what the simplified answer in a book would be versus the simplified answer on like an online calculator, and they won't always match. So also just like keep that in mind. There's not always like one right way, so it's kind of just do the best you can. But one thing I do want to tell you is to force yourself to figure out how to simplify. So if you look up an answer and you realize your answer is not as simplified as what a calculator did, force yourself to figure this out. This really takes practice. It is an art form in and of itself. It takes patience. But if you do things like make minus sign errors, or rather I could say if you are prone to small errors, then forcing yourself to simplify is a great way to get yourself to fix that. I hate to tell you this, but noticing errors, if you make small ones, it is a skill to learn to notice that. And you get really good at it by forcing yourself to practice like little things like simplifying. You will get a lot of aggravation from doing that. But trust me when I tell you that, like, learning how to catch these things, you start to develop an eye for it after a while. All right, so here's the last one if you want to really test yourself if you're getting this. So I've made this one a little hard and totally different. So now hopefully you kind of have developed that eye. So pause the video here, give this a try, hit play when you're ready. Okay, so I notice when I look at this, this is really the product rule. I have this function and this function, and I'm not going to worry about where the chain rule is. I just know that I'm going to have to use it a bunch, okay? So starting with the first one, I need to take the derivative of this function here. So looking at this, so let's see, I'm actually going to erase these. So the outer function is tangent, the inner function is 3x. So that's what I need to worry about right now, okay? So the derivative of tangent is secant squared, and I leave that inside function intact, and then I multiply that by the derivative of the inside, which is just 3. Okay, now remember, the product rule is dictating all of this. So this was the derivative of this guy here, and now I need to multiply that by the second function. And I'm not really worrying about the second function right now, other than just writing it down, because that is what the product rule tells me to do. Okay, so now we're going to pivot. I'm going to write tangent of 3x down, and now I have to take the derivative of this whole crazy looking thing here. Now I recognize that the outermost function is this e, and then here's where you got to turn your brain off. This whole thing is the inner function. I might see more chain rule here, but really as it stands, this is the inner function. Okay, so the derivative of e is just e. I leave the inside function intact. And now I'm going to work on multiplying this by the derivative of the inside function. Let's see. I'm probably going to run out of room, so I'll go ahead and write it here. Okay, so taking the derivative of this guy, the derivative of 4x is just 4. And then, boom, another chain rule. All right, we got this, though. So now the outer function here is cosine, and the inner function here is 3x. So the derivative of cosine is negative sine, so this becomes plus sine 3x, okay? And then I multiply that by the derivative of the inside, which will just be 3. Whew. Okay, so now, let's see. I've gotten all the pieces, so now it's just a matter of simplifying. Again, there's not a lot you can really do with this particular problem to make it, you know, beautiful. So, let's see. I'm just going to simplify this as best I can. Yeah, there's not a lot we can really do with this one. It's not a beautiful problem. Just a lot of stuff. Let's see, this times tangent of 3x. Let's see, can I fit that last part? And then I've got this e to the 4x minus cosine of 3x. So let me just do a quick sanity check, make sure I didn't lose anything in the process. That's a big concern I have. So here, so I brought the 3 in front, I've got the secant squared, I've got the second part, okay. Now for the other function, so I brought this set of parentheses to the front, and I got all that, and I rewrote this 3 in front, tangent, and then this. Yep, so this is as far as I can go with this. Okay, so just a few suggestions from here. So parting thoughts, if you really want to now test your understanding of this, I do have more chain rule example videos, or you can watch my video of really hard examples. So regardless of whether this is actually on your homework or not, this is a great way to see if you are really understanding the chain rule, and I will drop a link to that also in the description. Okay guys, so that's it for this video. If you thought this was helpful, I would super appreciate getting some likes on this or a comment. Also, if you are following my channel, consider hitting the subscribe button. And otherwise, thanks for watching guys. I'll catch you next time.